Good morning, folks. So here we are. It is Monday, the 2nd of November, and we are just finishing up our Biochem unit here in Living Environment. And so for today, in this snowy, blustery 2-hour delay that we have, I'm going to go over the absolute basics that you need in order to do well on the coming test. Remember, our test is going to be tomorrow, on Tuesday. So today is our review day, and we will use this time as best we can. So for the bare minimum, we will be utilizing the handy, the dandy, a whiteboard, and my phenomenal artistic talents. So let's start with the basics. All right. This review is entirely on the basics of exactly what you're going to need in order to do well. This is not the comprehensive 100% ace the test guide. This is the please, please, please get me a 70 guide. So keep in mind, for everything I do, there is more for you to know. So let's start. First things first. Remember, we have our 4 organic molecules. We have our carbs, our lipids, our protein, and our nucleic acids. I misspelled nucleic. No, I didn't. It was right the first time. All right, so there are our 4. Now, for each one, let's make sure that we know what they do, their primary function in the body. Carbs, remember? Are our source of energy. Lipids do a bunch of things. Lipids will store energy. They insulate. They waterproof. And they make up all of our membranes. Proteins, another one that's got a lot of stuff to do. It is the bones and muscle. They do transport, moving things around. They fight disease. And remember, they control our reaction rates. That RxN means reaction. And then finally, the nucleic acids. This is our genetic information. All right. So we have our 4. We have what they do. What do they look like? Well, remember, carbs are going to be that 6-sided ring. Lipids can come in 2 forms. You're either going to have your glycerol with your 3 fatty acid chains coming off of it, or you're going to have your phospholipid that looks like the little squiddy with the round ball head, the hydrophilic side, and the hydrophobic chains. Your proteins will always have the butterfly shape. So remember, they're going to have that central piece with your R group, and then the wing off either side. And finally, the nucleic acids, the most complex one, but also arguably the easiest to identify, because they're going to have that house. I always called it the cheerleader because there's an O up here. They're the 2 little legs holding a phosphate or pom-pom group on one side, and then having that nitrogen group on the other side. All right, but what are the key terms for each of these that we're going to need? Well, remember, for carbs, they come as either mono monosaccharide or polysaccharide. And some very common examples of those is our sugar, which is a monosaccharide, and our starch, which is a polysaccharide. In lipids, there are no such things. No monomer and polymer of lipids, they just are their unit. In proteins, remember the key here is going to be the amino acids. And the amino acids are the monomer. The amino acids build the protein. In the nucleic acids, our two polymers that we look at are DNA and RNA. And the individual subunit right here is called a nucleotide. So the nucleotides build both of those, monomer, polymer. Great. We've covered our 4 organic molecules. So now, why don't we move over a little bit on here to utilize this area? Because now we got to then talk about those enzymes. Remember, enzymes are proteins. They are a member of the protein group. And if you're given a diagram that shows something like this, you should be able to identify that this part that fits in, that is the substrate, and that this Pac-Man piece, this is your enzyme. That these two will come together. And then finally, the enzyme will break apart that substrate into the product. Number 1, number 2, number 3. The enzyme is the same at the end. Nothing for the enzyme has changed yet. Now, we can take an enzyme and we can very strongly influence its action. So there are 2 things that are of danger. To enzyme action. And if you change these, we can change how the enzyme is. And that's the temperature and the pH. Remember, if the temperature goes up or the pH changes, then it is going to change the shape of the enzyme by the end. And this means that the enzyme has been denatured. Destroy, deforest. We have removed the nature of the enzyme. We have stopped it from doing what it should be able to do. Now, because we mentioned pH, it would be good to talk about our pH scale, even just a little bit. So remember, the basic rules are always the same. 7 is neutral. If you go above 7, it's vanilla or pumpkin spice. If you go below 7, it's acidic. So 7 is neutral. A 5 is acidic. A 10 is basic. It just is based around this. That is our pH scale. And the last thing that you guys should know for this is going to be, what is an indicator? And remember, indicators are all about changing color to detect something. Let's see. There we go, kind of. So indicators change color. Benedict's changes from blue to orange when there are sugars present. Our Lugol's changes from that golden brown color to black when starch is present. Our Burette's changes from blue to purple when amino acids are present. And the old one that we can't use anymore, the Sudan 4, that would have changed from clear to bright orange red when lipids were present. So remember, we have indicators to tell us if something's there. Ladies and gentlemen, this is our unit for biochem. I hope this is helpful. If you need to, go back, pause the screen, roll back through the parts that you need to go over or memorize. Our test is tomorrow. So I hope everybody has a great day. I can't wait to see some of you here in person today and the rest of you a little later this week. Have a great day.